Draw each of the following angles in standard position. State the principal and reference angles. In Part A, draw 930 degrees and state the principal and reference angles. (930° is difficult to visualize since it is a large angle. The animation shows that multiple counterclockwise revolutions are required to position this angle. If we find the principal angle, we can just draw that. Start at 930 degrees, then subtract 360 degrees twice to get the principal angle of 210 degrees. Note that we can think of this calculation as unwinding our way back to the principal angle. The terminal arm is at 210 degrees, and the negative x-axis is at 180 degrees. The absolute value of their difference is the reference angle, 30 degrees. In Part B, draw negative 855 degrees and state the principal and reference angles. Negative 855 degrees is difficult to visualize since it is a large angle. The animation shows that multiple clockwise revolutions are required to position this angle. If we find the principal angle, we can just draw that. Start at negative 855 degrees, then add 360 degrees 3 times to get the principal angle of 225 degrees. Note that we can think of this calculation as winding up towards the principal angle. The terminal arm is at 225 degrees and the negative x-axis is at 180 degrees. The absolute value of their difference is the reference angle, 45 degrees. In Part C, draw 9 radians and state the principal and reference angles. Nine radians is difficult to draw because 1. It's in radian decimal form, and 2. It's a large angle that is more than one revolution. Let's convert this to degrees. Multiply 9 radians by 180 degrees over pi to get 516 degrees. Now find the principal angle. Start at 516 degrees, then subtract 360 degrees to get the principal angle of 156 degrees. The animation shows a terminal arm rotating to 156 degrees. The reference angle is the absolute value of 156 degrees minus 180 degrees, which is 24 degrees. Since the original angle was expressed as an approximate radian, we should convert the principal and reference angles to radians. The principal angle, 156 degrees, can be multiplied by pi over 180 degrees to get 2.72 radians. The reference angle, 24 degrees, can be multiplied by pi over 180 degrees to get 0.42 radians. In Part D, draw negative 10 pi over 3 radians and state the principal and reference angles. There are 2 ways we could draw this angle. 1. Convert to degrees, or 2. Count intervals of pi over 3. In this example, we'll use option 2, counting intervals. We know that pi over 3 equals 60 degrees, so negative 10 pi over 3 is the same as negative 10 times 60 degrees, or negative 10 times pi over 3. This means we can count out 60 degrees, or pi over 3 radians, 10 times clockwise to arrive at the angle. In the animation, we rotate the terminal arm clockwise by 10 intervals of pi over 3. This is negative 600 degrees. Start at negative 600 degrees, then add 360 degrees 2 times to get the principal angle of 120 degrees. The terminal arm is at 120 degrees and the negative x-axis is at 180 degrees. The absolute value of their difference is the reference angle, 60 degrees. Since the original angle was an exact radian, our answer should be 2. The principal angle, 120 degrees, can be multiplied by pi over 180 degrees to get 2 pi over 3 radians. The reference angle, 60 degrees, can be multiplied by pi over 180 degrees to get pi over 3 radians.